welcome to this video. My name is DARSHAN KATGERI and I'm working with Jain College of Engineering, Belgaum. In this video, we are going to solve a problem on isometric projections, that is on combination of solids. That is, we are going to solve this particular problem, which is shown in this small figure here. So let us move ahead and see what is the problem and how it is to be solved. The problem reads like this: the sphere of diameter 30 mm and it rests on a frustum of an hexagonal pyramid. So we have a frustum of an hexagonal pyramid like this here, and then we have a sphere placed on that, and the dimensions, that is the dimension of the top surface and the dimensions of the base of the pyramid, hexagonal pyramid, are given, and the axis length is also given to us, and it is told that the axis coincide. That means they are in line. The axis of the sphere and the axis of this frustum of hexagonal pyramid, they are in one line, and we have been asked to draw the isometric projections of the combined solids. So again, please note here it is projections, right? And you can see that the axes are in line here in this particular. So how to draw this, how to go about this problem? Again, note that this orthographic view will not be given because everything is given in a form of a statement. So we have to construct these orthographic views. We need this top view. This front view will be drawn only for completeness, but this is required. This top view is required, so we have to at least construct this top view, right? So how to go about this particular problem is what we are going to see now. So we will be drawing this hexagon first, and then inside this hexagon we will be drawing another hexagon whose length is 18 mm. You can see here it is given as 18 mm, and the base is 36 mm here, and its height is 50 mm, which can be seen here, and the diameter of the sphere is 30 mm, right? But what we should note here is that we will not be knowing these dimensions here, or these values, like for example this value here, this value here, right? And what is the distance of this corner from this particular point, this will not be known. So to get these distances, we have to draw this top view, right? And once you draw this, then you again imagine that it is enclosed in an box, and for example you can take this as a reference, so you can place this particular point and then you can measure this. So you have to always convert it into the isometric length. So if it is 15 millimeters, it should be isometric 15 when you mark it from here. So from here you can mark isometric 15, from here also you can mark isometric 15, and similarly we can mark isometric 15 from these particular points, that is this distance, this distance, and this distance, and this distance. So once you mark this, then we need the midpoints, so we can measure what is this particular distance here, this particular distance, and then we can mark. Otherwise we can directly mark the midpoints of the line, and then we are supposed to join these lines like this, from here to here and from here to here. Then we will complete this. I will take a different color. Then we will complete this box. We will complete the box like this. We will complete this particular box, and then inside this box we will be drawing another box, that is say this particular box that is required, this particular box that will be required. So that will be drawn here, right, by taking arcs again. by taking arcs and joining the lengths. I will be showing this in detail in the drawing. So you should join these lines and you should join these lines, and thus we will get one square here or rectangle, and in this rectangle we are supposed to draw this hexagon again, that is by measuring these distances here. For example, this distance here, just show this, say for example this distance here, this distance, and these distances are required. So this is what we are going to do, that is we are going to mark all the points on this box, and then we are going to obtain this inside rectangle, and then we are going to draw the top surface on this, and on this we are going to draw the bottom surface, and then on top of this we are going to place a sphere. So how to go about this, we will see, and I will directly solve this in solid edge. But before that, let me just explain you what is this frustum. This is the top view of a pyramid. Like for example, this, ignore this section here. This is the top view of the pyramid, hexagonal pyramid. And now if I move this, you can say cutting plane, this cutting plane will cut the hexagonal pyramid, and the section we thus obtain is an frustum. It is called as an frustum of an pyramid. So you can see that this is the top view. This is the top view, and the same view is here. However, in this visualization, I have not drawn the sphere on top of this, right? But whenever such an section is inclined at a particular angle, it is called as truncated pyramid, right? So, but this is an frustum of an pyramid. So this is what we are supposed to draw. So let us go to the software, and we will close all these things. We can get these back later. The first thing that we will do is we will do sheet setup. Go to A4 sheet, turn off the background, and say save defaults, and say OK, and then press on this fit screen, that is cross with arrows. So once you have this, now we can start drawing the hexagon. So I will go into this sketching option, and I will draw one hexagon. The base is 36. You can see this is the base, so we will draw this. So this is 36 millimeters, and first angle is 0. Next 36, and the angle will be 60 degrees. Then 36, and angle will be 60 into 2, that is 120 degrees. Then again 36 and 60 into 4, 60 into 3, right? And then again the length is 36, and the angle is 60 into 4, 60 into 4, and then we have to close this. So we can see that all these lengths are 36 millimeters. Now what we can do is we can join this from one corner to the other corner, from this corner to this corner, and from this corner here to this corner here. So this is the top view of the pyramid. I have to draw one more hexagon to show the top surface, but instead of drawing it separately, what I can do is I can use the scale command. So I will use the scale command, and I will give the scaling factor. So how to calculate the scaling factor? I need an hexagon of 18 mm sides, right? And I have an hexagon of 36. So what I will do is 18 divided by 36, that is 0.5. So 0.5 is the scaling factor. So it has created one more hexagon, and I will put on this copy mode, This particular mode is copy mode, and I will place the hexagon here, right? And at the center we are having a sphere, right? So the dimension of the sphere is 30 mm. So the diameter is 30 mm. So here I will put 30 mm, right? So this is how it is, and these lines are not required now. These lines are not required, so we can trim them. Also, these lines have to be trimmed because it is the top surface, like this. So now this is the top view that we will be requiring. We cannot start without this because we don't know what are the dimensions of the rectangle that we are going to draw, right? So let us start drawing the isometric projection of this. So I will draw one line of a certain length. The length is not important here, and I will draw another line from the center point of this. The center point is deactivated, so activate it and select the center. Now I don't know the length of this line, so I will take some arbitrary length. What is important is this angle, that is 30 degrees, right? So I will keep length maybe say this much, and on this side also I will keep the angle as 150, and I can draw one line this much long. Length is not important, the angle is important in this case. So this and this is 30 degrees, and this is also 30 degrees, right? So now we need to enclose this in an, because we need to draw this rectangle, so we will imagine that it is enclosed in an or in a box. So I will construct a box around this. I will take this inference, and I will come till here, and I will enclose this in a box. I will enclose this in a box. And what I need is the dimension of this box, that is this length and this length, right? So this length is 72 and this length is 62.35. Okay. Now I have to mark these lengths, that is the isometric of these lengths onto this. So I will go to arc by center point, and again remember here we will be drawing the isometric view first, and then we will convert everything into isometric projection. But when you are doing it manually, you have to actually calculate the isometric of 72, that is ISO 72, that is nothing but 72 multiplied by 0.81649, and whatever length you get, that length has to be marked here. But here, however, I am going to draw the view, that is why I am going to mark this as 72 mm only, right? And same is the case on this side also. I will mark 72 mm. The radius has to be 72 mm, 72 mm, and this length, so you just place it like this, okay? And this much is not required, so what I will do is I will trim off this side, and I will use extend to next and extend this line till this arc, and I will delete this arc. So now we have this basic setup. I will just move this a little to the side, little to this side. Again, I see that it is not 72, so I will go extend to next and pause on this line, and it will extend to the arc that we have drawn. Now this line is 72 millimeters, and this is also 72 millimeters. You can see the length here and the angle, and you can see the length here and the angle, right? Similarly, I need to draw two more lines. So I am using a software, so it is easy for me to draw these two lines because I can use this command to increase the productivity, right? So I will place it here, and I will select this line, and then we can place it from here to here. So the length of this line is 72, this line is 72, this line okay. Okay, this line is 72. Actually, we have to draw this 62.35. We have committed a small mistake. Let's rectify that. We will make this line as 62.35, right? So 62.35, right? And we will make this line also as a 62.35. 62.35. So we will move this line back from this point to this point here, and also we will move this line back here from this point to this point. Now everything should be all right. This is 72, this is 72 millimeters, and then this line is 62.35, this line is also 62.35. So now we are all set. We don't need these arcs anymore, so we can either hide them or put them in layers and hide them. So let's continue. Now what I have to do is I have to mark these points. So to mark these points, first of all I need to measure these points. So I need the distance from here to this point, that is the horizontal distance. It is 18 millimeters. Also you will see that these distances, that is from this point to this point, it will also be 18 millimeters. So all these distances, this distance, they will all be 18 millimeters. So I have to draw an arc of 18 millimeters. So this is 18 millimeters. You have to draw one arc here, and from this side also you take 18 millimeters and draw another arc on this particular side, and another 18 millimeters. There are shortcuts to this, but I am doing it in detail. This is how you would be doing it on the sheets. So that is why I am also doing it as you would do it on the sheets. Right? So this is also 18 millimeters, and you draw an arc, and we need this distance also. We will just move this a little bit. This is the midpoint, so we need this distance, that is from this line to this particular point here, which is 31.18. So again I will go to arc by center point here, arc by center point, and from here it is 31.18, and draw this arc, and on this side also we need one arc of 31.18. So this radius will be 31.18, and you draw this particular arc, right? So now the basic is a basic structure that we want, or the points that we want. We have marked all the points. Now we can join these points. So I will change the color of the line and the thickness of the line, and I will zoom in and I will mark these lines. So here and here also I have to take the interaction, the intersection, sorry. For time being, you can just turn off the midpoint, and then you can come back and you can easily get the intersection. Zoom out, and here also you will get the intersection. Again, here also you will get intersection. So you have to find the point, intersection points. Be little careful while doing so. So now once we are done with this, what we can do now is we have to construct the box, right? So to construct the box, we need the height, and the height is given as 50 millimeters. We will go back to the software and we will draw one line of 50 millimeters. So this line will be 50 millimeters and it will be at 90 degrees to the horizontal. I will change the thickness of this line and I will use move command. So I will move it with copy on, of course, from this point to all these points here. And we can take all these lines that we had drawn and again use this move command from this point to this point, right? So all this, what we are going to do is we are going to draw this particular hexagon, that is the top surface, for which we have to imagine another square. So let us change the color a little bit. So yes, I will take the inference here and the inference here. Yes, it is taking a tangential to this, so I don't want a tangential. Then again from here till here. Yes. So now we have to somehow get this square here. So for that, what we can do is we can just extend these lines. So that is, we can just extend these lines on either sides like this, and like this. And now we have to get these distances here, that is from here to here and from here to here. And once we get these distances, we will join the lines and get the other points also. So let's go ahead and do that. I will move this a little bit. There seems to be some problem. Yeah, I will move this a little bit to here. Yeah, now we can move this, and we will move this also a little bit to the side. I am doing this only for clarity. Now I need the distance between this and this, because I already have, we find that in this case it is coming out to be 18. So it is going to be very easy for us. And we need this and this distance also, which is 15.59. This is 15.59, right? So all these distances, this distance here, this distance, this distance, this distance, all of them will be same. And now we will mark these points. So arc by center point. So what we can do is we can mark these 18 mm here, this 18 mm. I can use all these that I have marked, but since I am doing this as the way you will be doing it on the sheet of paper, that is why I am doing this in detail and in this particular way. This has to be 18 mm, right? So let's mark this. Let's mark this like this here. So once we are done with this, then the same has to be done on this side also. So this is 18. Make sure that they are 18 mm. And on this side also we can do the same. That is, this is the center and 18 mm is the radius. So just draw this here. And on this side also 18 mm is the radius. Here 18 mm is the radius, and the sweep angle is given as 18, doesn't matter. So this is what we need. And next we need 15.59. so 15.59. So again arc by center point, and from here I need 15.59 radius. So I will draw one radius here, and again from here 15.59, 15.59 enter. Sorry, the radius has to be 15.59. The sweep angle is not very important to us. Okay, so there is no need to do all of this like this in the software. There are shortcuts, of course, but I am doing it in detail as you do it on a piece of paper. So now we can use the move command and move this line from this point to this point. Then this has to be 18, this has to be 18 mm, this is also 18, this is also 18. So let's take the intersection from here to the intersection here rather. So this is what is required. You will see that the angle will be 150 degrees. So similarly you can go ahead and join these two points here. So you can join this point to this point like this, and then you can merely join this. That is, you can use move command and move this line, say from this point to the intersection of this and to the intersection of this particular point here. Right. Let us change the color of these lines. Yes. So let me change the thickness of these lines. Yes. So these blue color lines, so this is what we require. Now we have to plot this particular hexagon in the square that we have obtained. So I will take the dimensions from this point to this point, which is 9 mm, and everywhere it will be 9 mm. You can measure and see. I will show one of the measures here. From here to here, again it will be 9. So on this side also it will be 9 only. So again from here to here it is 15.59. That is the midpoint, right? So now these measures are from the inside square or the blue square. So while marking also we should be very careful. So arc by center point, and from this I have to mark 9 mm, right? So this has to be 9 mm like this, and you mark an arc, and from this side also it has to be 9 mm. Sweep is not important, radius is important to us. So on this side also it is 9 mm. So draw this, and from here also it will be 9 millimeters. Again you draw an arc. It's not working properly, so let's zoom in a little bit, and 9 mm. The radius has to be 9 millimeters. So we will give this radius here, and from here it will be 9 millimeters, and from here to here, right? And this distance, this particular distance is 15.59. So again I will come here and I will select arc by center point. So this is the point of interest for 15.59. So the radius is 15.59, and you can mark here, and this also 15.59, and sorry, this is 15.59, 15.59 here, and we can mark this distance like this. And finally, we have to join these. So let us change the thickness of these and join these. So join the intersection points properly. So you have to use the inference again. You can see this, yes, intersection and end point. So this is the top face of the hexagonal pyramid. Finally, you can go ahead and join these slant edges of the pyramid. Join it from the end point of this line to the end point of this line, the end point of this line to the end point of this line. And I will now change the thickness a little bit, and I will join it from here to here and from this point to this point. And I will change the thickness of these lines, and even this particular line I will make it say 0.8. So I will change the color of this. So I had changed the color only for clarity. Yes, like this. So this is the frustum of the hexagonal pyramid that we required. Now on top of this, we are supposed to place a sphere. On top of this, we are supposed to place a sphere, right? For which we need the center. So how we can mark the center of this? So we can mark the center. Say I will draw one line at 15.59, which will pass through here, and then I will take one more dimension. Say for example, from here to the center point, which is 18 millimeters, right? So that is from this particular reference, it is 18 millimeters. So I will go arc by center point and 18 millimeters. I will draw an arc here, and if I join this line here from here to here, this is the line joining the midpoints, and a line joining from the intersection to the midpoint of this particular line, it is deactivated. I will activate it. So say the midpoint of this line, then I will get the center, right? Then I will get the center of this, right? So what I have done is I have joined this and this, and this center here and this center here, right? I will be getting the midpoints. The same thing I have done here, so I will be getting the midpoints. Now from this center I have to draw an axis. Now please note here, from this center the length of the axis will be isometric. Okay. This length has to be isometric, but since now we are drawing the view, we are going to draw it actual. So the dimension is 30 mm. So the length of this line, that is the radius, is going to be 15 mm, because the because the diameter is 30, its radius will be 15, and here I will give angle as 90, right? So the center of the sphere will be here, that is this particular line. I will make this axis line, and now what I will do is I will convert all of this. This is important. At this stage, when I have drawn the axis, at this stage I will convert all of this into isometric projection. This is the view. Now I am going to multiply this by a factor of 0.81649, I don't want a copy, and I will place it here, right? So before drawing the sphere should be always drawn in actual dimensions. So this is very important. So this has to be scaled or converted into isometric projection before drawing the sphere. And to draw the sphere, I will take a circle, and I will take actual dimension or the given dimension or true dimension, which is 30 millimeters, right? So from this point, that is this particular point, I have to draw 30 millimeters. So this is 30 millimeters. So I will select this, and we can change the thickness of this. Now some small things are remaining, that is I have to split the line. So split this particular line at this point, and then split this line at this point here, and select these lines. You can zoom in, select these lines and make them very light. So you can see that this is actual 30, right? Whereas the axis is isometric 15, that is the radius, right? So this is very important. And then finally we have to save this drawing. So this is a complete solution. This is what is expected. Of course, we can put all of these small things onto layers. So let us go ahead and do that. I will create one new layer, and I will just say the name of the layer as construction, and all of these lines which are a part of our construction, I will put all of these lines onto this layer. So right now I have selected these many lines, and I will say move to construction, say OK. We can hide and show these lines. So I will select all of these arcs also. So all of these small things, small arcs rather. So if anything is left out, you can select all of them. So here I have left out this arc here, and here this arc, and yes, we can move them into the construction layer. Yes, some are left out. So like this, if anything is not required, we can move them into different layers. Yes, even this line will be moved to this layer. So this is what is expected. Okay, even you can also put even these things onto layers. Axis needs to be shown. So even these things on the layers, this one, you can create a different layer if you want, but I am creating only one layer, say like this. So these things can also be moved to the layer. So now this is the complete solution. This is the isometric projection that we were expecting. Okay. So you see that again the front view was not required. However, we can go ahead and draw the front view for completeness. In this video I am not going to do it because the video will be too long otherwise. So this much is the solution. This is what we are expected to do. Remember this has to be isometric, and then it has to be converted, and finally when you draw the sphere, Finally, when you draw the sphere, it has to be actual, right? So this radius has to be actual radius 15. Okay, so please take care that it has to be actual 15, and this length from here to here, it has to be isometric 15. This length has to be isometric 15. So this is important to note here. So this is important, right? So this is the complete solution. You can solve this problem on the grid sheets and save it as PDF and then take the printouts. Thank you.